Okay, so let's talk about parallel and perpendicular vectors. We know from the previous video on vectors that the scalar or dot product of two vectors can be gotten by the magnitude of one vector times the magnitude of the other vector times cos theta, where theta is the angle between those two vectors. Now, if you think, let's go for perpendicular first. So if we've got two vectors that are perpendicular, then the angle between those two vectors is 90. So let's have a look. If we did have here, I'll do it in a different colour. So if we had u v cos 90, so what do you know about cos 90? Cos 90, try it in the calculator if you can't remember, or think of the cos curve. So there's 180, 360, 180, 90 is right there. So you get a 0. So you're going to get 0 times anything is 0. So you're going to get u dot v, so the dot product being 0 for perpendicular vectors. So that's handy to know. So for example, if you had to show two vectors, let's say u, oh that was bad, sorry, u equals that, and vector v is 3, 5. So you can already tell, because you know gradient rise over run kind of thing. You can see that one's 5 minus 3, the other one's 3, 5. So hopefully you can kind of see that they would be perpendicular, but let's just have a look. So if we do the dot product, so we get 5 times 3 is 15 plus 5 times minus 3 is minus 15. And we get 0, therefore those vectors have to be perpendicular. And so, if I didn't explain it very well last time, but if, for example, vector u, so we go across 5, 1, 2, 3, 4, let's say here 1, 2, 3, 4, 5, and I'm going down 3, 1, 2, 3, so there's that vector there. If I go across 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, there's that vector there. So you get this nice 90 degree there. Not that you do that, but anyway. Alright, so that's perpendicular. Alright, so we might just leave that there. So what about if we're talking about parallel? Alright, there can be kind of two sorts of parallel. So we could have two vectors, let's say that one, and they're parallel and they're going in the same direction. So really the angle between them would be 0 degrees. So let's have a look at that. So we're going to have u dot v being equal to u magnitude v magnitude cos of 0, and again, should have got rid of my cos curve. So cos of 0 we know is 1, so you would just get u v there. So this is if they're parallel. Alright, so if they're parallel vectors, we're going to get the dot product is just the multiplication of their magnitudes. Same thing, if they were going in, they're parallel but going in the opposite directions, we would say the angle between them is 180 degrees. Now, cos of, there's 360, there's 180 there. So cos of 180 is -1 instead of 1. So you would get, in this case, u dot v equaling, so because of 180, so we've got negative magnitude, like that. So that's also parallel. So whether it's positive or negative, it's going to be parallel there. So for example, if I had two vectors, let's say my u vector is 4i plus 3j, and my v vector is 6i plus 4.5j. That should be an I there. And I'm interested to see if they are parallel. Well, let's have a look at u dot v. So we know u dot v is 6 4s and plus, so there, I'll write it like that. So 4 6s plus 3 lots of 4.5s. Maybe use my calculator there, and we would get, you can check for me, 37.5. Now, if they are parallel or perpendicular, obviously that's not 0, so it can't be perpendicular. If they're parallel, then they're going to equal to plus or minus the magnitudes times. So if I look at the magnitudes multiplied, so the magnitude of u, remember, is, so we've got 4 squared plus 3 squared, which we know is 5. And then the magnitude of this one, 6 squared plus 4.5 squared. Well, that's an interesting one. So that is a 5. 6 squared plus 4.5 squared and square root, use your calculator. Should be 7.5. So if I multiply those two, again, I've run out of room, I'm getting 37.5. So you can see that I'm getting u dot v equaling the magnitude of u times the magnitude of v. Therefore, I know they must be not only parallel, but heading in the same direction, because that wasn't a negative. If one was negative, so if this was a negative 37.5, I would say, look, they are parallel, but they're heading in opposite directions. So hopefully that helps you understand that.